And what was your favourite thing about working on the project?
The combination of biochemistry and analytical chemistry was really fascinating, and you could actually see your results being transferred into another part of the project, and then you got a feedback, and then you could continue with your project. So I think this intercollaboration is really amazing about this project.
Hello, and welcome to Technology Network's latest video series, Science Spotlight. Today we're hearing from Tereza, who's here to share her exciting research. So let's dive on in. So, could you tell us a little bit about yourself and the incredible research that you've been doing?
So hello, my name is Tereza Jaegerova, and I study at the University of Chemistry and Technology in Prague. I'm in my last year of PhD studies focused on analytical chemistry in food and natural products. And just recently, I've been engaged in a project looking at secondary metabolites of Dyer's Alkanet, which is a plant possessing different bioactive properties. And this is the work that I would like to introduce you to. As I have already mentioned, this is the overview of my poster concerned with the work on the chemical profile of Dyer's Alkanet, and I would like to introduce it in more detail now. So we have selected this plant for our study because recent research has suggested some bioactive properties, especially of the roots. This plant has been well known for a long time for its red pigments, but we were interested to see whether it possessed also some antimicrobial activity. This activity has been described in recent literature against some microbes, but we wanted to expand on that portfolio. And some of the bioactive compounds have already been described in the literature as well, but we wanted to look at the more general profile of secondary metabolites and also try to identify some potential bioactive compounds. And so this leads me to the study objectives. And as mentioned, so we used the roots of this Alkanet tinctoria plant, and we tried to optimize the extraction and analytical method, and tested the samples on different microorganisms. And in the end, we tried to isolate and identify the bioactive compounds. So as you can see here, this was the study workflow. We have purchased the roots of Alkanet tinctoria in online shops. And the first step was to optimize an extraction method for the highest yield of our bioactive compounds. So we tested different conditions, different extraction solvents, different extraction methods. We then tested these obtained extracts on the bioactivity, on the antimicrobial activity, and we checked which extracts worked the best. And these extracts were then fractionated using the preparative high-performance liquid chromatography method, and we obtained several fractions, and these fractions were once again tested on the antimicrobial activity. And those fractions that were active, we then analyzed in more detail using our newly developed ultra-high performance liquid chromatography method coupled to tandem mass spectrometry. These are the results of my study. We have found out that the best extraction solvent was ethanol with shaking. In the middle, you can see a figure showing the total compound chromatogram for different extracts analyzed on a reverse phase in a negative ionization mode. And as you can see, the profiles differed. But we found out that the aqueous extract was not active against the tested microorganisms at all, while the ethanolic and hexane isopropanolic extracts were more or less comparably active. And because we also detected more metabolites with the ethanolic extract, we decided to go with that extraction solvent. So once we had the extraction method optimized, we then fractionated the sample using the preparative HPLC, and we obtained 30 different fractions containing different compounds. And four of these fractions were actually showed actually again antimicrobial activity against G plus bacteria. So this is important to mention that we have tested bacteria, fungi, and yeast, and the extracts as well as the fractions were only active against the G plus bacterium. And so we then analyzed the chemical profile of the bioactive fractions to see what's inside, to be able to assume which compounds were responsible for the antimicrobial or antibacterial activity. And so we found out that the fractions contained mostly naphthoquinones. So we were able to identify 17 of these naphthoquinones. And we also looked at the profile of phenolic compounds, which we found out that was actually poor in these fractions. So we really concluded that these naphthoquinones were responsible for the observed antibacterial activity. And we have also, for the first time, shown that this root of this plant is actually active against Cutibacterium acnes, which can be, of course, a valuable information in order to use these extracts in cosmetics and pharmaceutical industry, for example.
So that was really, really great. Thank you so much. So I do have a couple of questions I really want to ask, having heard everything, just to learn a little bit more about your research. So your poster showed that your extracts worked well against gram-positive bacteria, but not gram-negative. Any ideas why this is and what it might mean for possible uses of the extract?
This is quite a difficult question to answer because compounds showing antimicrobial effects, they can act in different ways, targeting different mechanisms of the bacteria. And we haven't really looked into that mechanism yet. But the difference between gram-positive and gram-negative bacteria is in the structure of the cell wall, where gram-negative bacteria have a thinner cell wall, but it's surrounded with a lipopolysaccharide membrane. So one assumption that we could make is that the compounds were not able to get through that membrane to act.
Got you. So then, what were some of the sort of biggest challenges that you faced during the extraction and fractionation processes, and how did you overcome them?
During the extraction, it was definitely to select the appropriate extraction method because you start not knowing which bioactive compounds you're looking for. They could have different chemical properties. So you want to select a procedure that yields the highest amount of these compounds, but you don't know what you're looking for.
Yeah, no,
So
absolutely.
yeah, we were able to overcome this problem because we actually tested the different extracts that we obtained for the bioactivity. So we could see, even though we don't know what we're looking for yet, we could see which extracts were most bioactive. And so we could then tell, okay, this procedure best suits our compounds. And for the fractionation method, one of the biggest challenges is that you introduce a sample into the preparative HPLC, and as you obtain the fractions, your compounds get diluted. So when you obtain these fractions, they are much more diluted than the original sample, of course, and so you cannot, or usually you cannot test them directly. You have to concentrate them. So luckily, we worked with nonpolar solvents. These are easily evaporated, so you can concentrate your fractions easily. But when working with aqueous samples, for example, it gets more tricky because water is not easily evaporatable. So you have to use, for example, lyophilization or some other mechanism.
Yeah, pretty tricky. So, how do you see your work influencing the future of kind of antimicrobial research or natural product development?
I think our results they have kind of expanded the understanding of how this plant works and the portfolio of microorganisms that was tested. And the interesting outcome was that it was active against the Cutibacterium acnes, which is a common bacterium causing acne and other skin-related issues. So I think it's good to know that this extract can be used in cosmetics and other fields. On the other hand, we didn't test any toxicity of the extract, so definitely some future work should also look into the toxicity to
Fantastic.
humans.
Well, thank you ever so much for sharing your fascinating research. It's been brilliant speaking with you. And if anyone wanted to get in touch with you to chat about your poster or your research, what's the best way that they can do that?
They can reach me via my email. I think that would be the easiest,
Perfect.
or on social
Wonderful.
media as well.
Yeah, of course. Perfect. Well, thank you ever so much.
Thank you.
Thanks so much for watching this Science Spotlight episode, and I hope you'll like and subscribe, and I hope you'll come back and see us again very soon.